Welcome to Public Day at the International Astronautical Congress. Just by show of hands, raise your hand if you've been to an IAC before. We got a good number. Raise your hand if you've never been to an IAC before. An even bigger number, fantastic. Well, this is a big deal for the United States of America to host this conference here. We have the opportunity to showcase what we are doing as an agency. By the way, just so everybody here knows, my name is Jim Bridenstine. I'm the NASA administrator. So I have the honor of leading America's space agency in exploration and discovery and science. And here in Washington, D.C. this week, we have been hosting the International Astronautical Congress, where all of the nations of the world that are interested in space, that want to have space agencies, that have space agencies, we convene and we talk about what we're all going to do together when we explore space. Because here's what we know. Science matters to all of us. And as we make discoveries and we explore, we all want to be able to share that information. We don't want to duplicate efforts. We want to keep going further and go further and faster than ever before. And of course, we can all do that when we work together. And that's what the International Astronautical Congress is all about. And we've been hosting it here in Washington, D.C. this week. Next year, it's going to be, in fact, in Dubai. So we're looking forward to that as well. And I would encourage all of those that are here to consider going to the one in Dubai a year from today. But here's the thing. There's a couple of things that I want to start with that are important. Some major discoveries, and I know this. There's a lot of people in this room that maybe are not involved in the space industry. This is Public Day. This is the day when people from the public who might not otherwise be involved in space have the opportunity to come to the IAC and hear what NASA is up to. And I've got about an hour, I'm being told 56 minutes according to the clock here, to give you an update as to what NASA is up to. But to start, I want to share some things I think that are absolutely remarkable. We had 2 rovers on Mars not too long ago, Spirit and Opportunity. Opportunity lasted 15 years, Spirit lasted 10 years. And these little rovers on Mars gave us some significant discoveries. Because of these 2 little rovers, we now know that Mars had an ocean in its northern hemisphere. That ocean constituted 2/3 of the northern hemisphere of Mars. We know that Mars had a thick atmosphere, and Mars had a magnetosphere because of these 2 little rovers. In other words, at one point in the history of Mars, it was habitable. It could have hosted life. Do we know that it did? No, we don't know. But I'll tell you what, we want to go find out. But I want to tell you something else that's important. Within the last year, maybe the last 15 months, some really amazing discoveries have happened. Number one, and this is because of Curiosity rover, another rover that is still active on Mars, and the InSight lander, here's what we know. We know that Mars is covered with complex organic compounds. In other words, the building blocks for life are on Mars. Does that mean life is there? We don't know. But we know that the building blocks for life exist on Mars. We know that they don't exist at all on the moon, but they are in fact all over Mars. The probability of finding life on another world just went up. We also know in the last 15 months that the methane cycles of Mars are commensurate with the seasons of Mars. Does that guarantee life? No, but it is an indicator. It could be geological in nature, but it also could be an indicator of life. The probability of finding life on another world just went up. Finally, here's what else we have discovered, and this is with our international partners. Liquid water on Mars, 12 kilometers under the surface of Mars. What do we know about liquid water on Earth? Wherever it exists, there is life. Is that true on Mars? Again, I don't know, but we need to go find out. This is something that is important to NASA. It's important to the United States of America, and it is in fact important to humanity. There is one person that I know who is more interested in finding life on another world than any person I have ever met in my life. And I had a very distinct honor a very distinct honor to serve with this gentleman in the House of Representatives. This is somebody, and I'm going to introduce him here in a few minutes, but I want to tell you what I know about him personally. He was an appropriator. In fact, he chaired what was called the Commerce, Justice, Science Appropriations Committee here in the United States House of Representatives. This was something that was on his heart. It was a desire of his to chair that committee for a reason. He wanted to go find out if there's life on other worlds. And as chairman of that committee, he had oversight of NASA. He was able to make sure NASA had the funding it needed to achieve its objectives. And he was one of those appropriators that made sure, and this isn't normal in Congress, but he told me this. He told it to me over and over again. He said, I will never put a mission on you that I also don't fund. And he worked bipartisan across the aisle, Republican and Democrat alike, to make sure that NASA had the resources it needed to go find life on other worlds. I want to introduce to you somebody who I consider a dear friend, Representative John Culberson. If you'll come up. The Honorable John Culberson. Whoops.
Thank you. Thank you so much.
We are honoring Representative John Culberson with what is called NASA's Distinguished Public Service Medal. This is the absolute highest medal that we can give to a citizen of the United States. We are so grateful for all of your leadership and all of your help, and oh, by the way, all of your funding for our missions. So with that, I'd like to give you this medal. This is the Distinguished Public Service Medal from NASA.
Jim, thank you.
Absolutely.
Thank you very much from the bottom of my heart. Thank you. Jim, thank you. This singular honor is all the more meaningful to me because it has been presented by, in my opinion, the very best administrator NASA has ever had in my 18 years in Congress. You're the best cheerleader the agency ever had and the most knowledgeable.
Just so you know, there's other NASA administrators here.
Thank you, Jim, for this important recognition and for all your help during our time together in Congress to help lift up America's space program in a bipartisan way. We always did so in a bipartisan way. I especially want to thank my wife, Belinda, and our daughter, Caroline, for putting up with all the aggravations and long separations caused by my public service, and for enduring my lifelong obsessive fascination with scientific discovery and space exploration. I also want to thank my new law partner, Kevin Kelly, for helping me better utilize the power of the purse as an appropriator, as a chairman of the Commerce, Justice, Science Subcommittee to enforce the law as the founders intended. The power of the purse is the most important check and balance in the Constitution. And I want to thank Kevin for helping me get started so successfully in this new phase of my life. Above all, I want to thank the voters of West Houston for entrusting me to represent them in the United States Congress for 18 productive years. They supported me in all of my most visible work, expanding Interstate 10 in West Houston and rebuilding after the devastating floods of Hurricane Harvey. But the voters of District 7 also supported me in my less visible work in support of medical and scientific research and the work that gave me the greatest joy of all to restore our space program and to lift NASA funding as close as I could get it back to the glory days of Apollo. Thank you. One of my heroes, the great Mars scientist Steve Squires, told me that Carl Sagan often said that exploring the solar system and homesteading other worlds constitutes the beginning much more than the end of history. I am so fortunate to have had the privilege to help make that dream come true for the American space program. With the help of my colleagues and the support of my constituents and my family, in my 4 short years as chairman of the Commerce, Justice, Science Subcommittee, we were able to significantly increase overall NASA funding. We doubled the planetary science account so that we can finally, thank you, finally, have and that's really important, because by doubling the planetary science account, we can finally have the proper balance and launch cadence of flagship, New Frontier, and Discovery class missions. And they won't have to fight each other so much anymore, and everybody gets a chance, and you can pick the best mission, Mr. Administrator. And best of all, working together in a bipartisan way, we ensure that it will be an American orbiter and lander, as part of an international team, that will be the first in human history to seek out life in the hidden worldwide ocean of Europa. And we laid the groundwork to ensure that it will be an American spacecraft, as part of an international team, that will be the first interstellar mission to travel to the nearest Earth-like planet with a spectral fingerprint of life in its atmosphere. The most exciting and meaningful part of my 18 years in Congress has been my work with all of you in the space program, all of you who can see over the horizon into the far future, and to help you make those dreams come true. Because I share the same passionate belief of my favorite founding father, Thomas Jefferson, who often said, "I like the dreams of the future far better than the memories of the past." Thank you very much. Thank you, Jim.
All your help, brother.
Thank you. What a joy. Thank
absolutely.
you. Thank you so much.
Well, thank you, Representative Culberson, for your leadership in the House of Representatives. And of course, you're not done yet.
I'm not done yet.
He calls me to make sure that I'm following the laws that he wrote when he was in the House. And we're very grateful for that. So keep it up.
All right, sir.
All right. Thank
so
you.
much.
Always.
Thank you very
Yep.
much.
You
Thank
bet.
you.
All right, my friend. Okay, so we talked a little bit about what we have found on Mars. Know this, we have done not just all these rovers on Mars, but one thing that I think is important to remember is in November of last year, we landed on the surface of Mars for the 8th time in human history with a lander we call InSight. And when we landed on Mars with InSight, it was on the cover of every newspaper worldwide. And really, for the first time, I saw just how impactful this little agency called NASA, that receives less than 0.5% of America's federal budget, how impactful this can be all around the world to inspire children and really shape the imaginations of children, not just towards exploration, science, and discovery, but also shape it towards the United States of America and how we want to build a coalition of nations. When we landed InSight on Mars, we didn't do it alone. Yes, it was an American spacecraft, but we went with international partners. And when our international partners were with us, on the cover of all the newspapers worldwide, it talked. There was the last paragraph, and all of the articles talked about all of the instruments from our international partners and the technology from our international partners. And that, I think, is inspirational for everybody in the world when we lead these efforts. And we're able to do that because of the support and help of John Culberson and, of course, members of Congress that are in the House today and the Senate. But InSight was the beginning of my time as the NASA administrator. Just a few short months after we landed InSight on Mars, which was absolutely spectacular, we had the opportunity to enter orbit around Bennu, an asteroid in deep space. We entered orbit with a little spacecraft we called OSIRIS-REx. OSIRIS-REx is right now in orbit around Bennu, and it is going to go down and grab a piece of Bennu and bring it back to Earth. For the first time, America will do an asteroid return mission. And I think that is going to be a significant achievement. Japan has done one with Hayabusa. Japan is already doing Hayabusa 2. And now we're going to be able to exchange samples internationally not just exchange samples, but have our scientists and their scientists working side by side to evaluate the samples that come back from these two very important missions, the United States and Japan, each leading their own missions to these asteroids in deep space. That happened, I think it was on December 27th. And then on January 1st, we had a little spacecraft that we call New Horizons. This little spacecraft called New Horizons, which gave us the beautiful images of Pluto in 2015. Raise your hand if you saw those images of Pluto in 2015. They were phenomenal. Thank you for doing that. I just got to know my audience, right? So those beautiful images of Pluto were not the end. They were the beginning. New Horizons kept going, and it went way out to what we call the Kuiper Belt, where there's all kinds of objects in deep space. We're talking about 4 billion miles from Earth, and we got these beautiful images of something called Ultima Thule, an asteroid in deep space that is in fact what we now know to be a binary contact, 2 asteroids that came together, and we are still getting absolutely beautiful images back from the New Horizons spacecraft that gave us the beautiful images and the science and the data on Ultima Thule. Now, while we're on this topic of New Horizons, there's something else that I think is important to note. 2006, many of you in this room are aware that Pluto got downgraded from a planet to a dwarf planet. Boo, I hear some people booing. That's my sense. So that happened before these images we got in 2015 and before the science that we got in 2015. And some people have argued that a planet, in order to be a planet, you have to be able to clear your orbit around the sun. Well, what we now know is that if that's the definition that we're going to use, you could really undercut all the planets. They're all dwarf planets because there isn't a planet that clears its entire orbit around the sun. That being the case, I think it's a sloppy definition. Many of you have heard me say this publicly. I think the way you should define a planet is based on its intrinsic values, not the values that constantly change like orbital dynamics. So when I think about Pluto and what we got back from New Horizons, here's what we know. Pluto has an ocean under its surface. Pluto has complex organic compounds on its surface. Pluto has a multi-layer atmosphere, and Pluto has its own moons. I'm here to tell you, as the NASA administrator, I believe Pluto is a planet. And I'm going to continue to tell everybody that I believe Pluto is a planet. And I know there's a lot of scientists out there that agree with that assessment, and we need to keep letting people know, because that New Horizons mission was amazing, and it's giving us great information. Okay, so from New Horizons, in February, we saw the Crew Dragon, one of NASA's commercial crew programs, attached to the International Space Station. We are on the cusp of, once again, launching American astronauts on American rockets from American soil for the first time since the retirement of the space shuttles in 2011. And I want to be clear, we need to return to that activity, and we need to go with our international partners. We're looking for all of our international partners to step up and help us as we work to commercialize low Earth orbit. Here's what we're trying to achieve. We are using the International Space Station for really 2 lines of effort for an eventual commercialization of low Earth orbit. These 2 lines of effort include industrialized biomedicine. And here's what we're trying to do. We're looking for breakthroughs. We need breakthroughs that will transform how we live on Earth. And when those breakthroughs occur, capital will flow into what will be commercial habitation capability, commercial space stations in low Earth orbit. So how do we do that? 2 lines of effort. Number 1 is industrialized biomedicine. Right now, we are using the International Space Station to compound pharmaceuticals and create immunizations in ways that we cannot do here in the gravity well of Earth. Right now, we are using the International Space Station ultimately to print in 3D human tissue and eventually human organs using adult stem cells with the purpose of transforming lives here on Earth. We're using the International Space Station to create artificial retinas in orbit. These are things that you cannot do here on Earth because of the way materials are layered, but you can do it in the microgravity of space. And when it is successful, and by the way, imagine this. Imagine a box that fits in the palm of your hand. Up the box goes with materials inside, and when that box comes back to Earth, 1,000 artificial retinas. So people who have macular degeneration don't have to lose their eyesight. I'm not saying it's going to happen. I'm saying we're working on it day in and day out. We are using the International Space Station to create these breakthroughs that will result in capital formation so that we can have a day of multiple space stations funded by commercial industry so that we can continue to have a presence in low Earth orbit. And NASA, of course, will always have a presence. I want to be clear. NASA will always have a presence. We will always be a customer. But just like what we are doing with commercial resupply to the International Space Station, NASA wants to be a customer. We want to be one customer of many customers in a very robust commercial marketplace in low Earth orbit. And we want to have numerous providers that are competing against each other on cost and innovation. Why? Because that's how we drive down cost, that's how we increase access, and we're doing it right now with commercial resupply to the International Space Station. We eventually want to take that, and we're almost there, we're on the cusp of doing it with commercial crew to the International Space Station, with 2 separate providers that are competing on cost and innovation. And by the way, there could be others, and we're very anxious about making sure that there's opportunities that go beyond what NASA has already funded. But then eventually what we need to do next is we need to see habitation in low Earth orbit that is commercial in nature. So we need that industrial biomedicine to be successful, and we need advanced materials to be successful as well. We talk about Z-band and fiber optics. These are just some of the capabilities that we are using the International Space Station to prove out that you can create very pristine, clear fiber optics in a way that ultimately, if it's achievable, will reduce the cost of fiber optic networks here on Earth. The business case closes, and capital will flow to commercial habitation and, in fact, in-space manufacturing in ways that right now does not exist. We are using the International Space Station for commercialization. I want to be clear. Some people would suggest that the International Space Station competes against private habitation in low Earth orbit. That is fundamentally untrue. We are using the International Space Station to enable our commercial operators to ultimately be successful. So in low Earth orbit, commercial resupply, commercial crew, eventually commercial habitation. Here's what we know. We do not want a gap in low Earth orbit. You know, we had the challenge with Apollo is that it ended. And ultimately, when it ended, we had an 8-year gap before the shuttles. And then we had the shuttles that ended. And now we've had another 8-year gap before commercial crew. We want to make sure that we do not have a gap with presence in low Earth orbit. There are kids graduating from high school today that have lived their entire lives with Americans living and working in space. And by the way, international partners with us living and working in space. That's a fantastic development for our country. It's a fantastic development for the world. We want to make sure that that never breaks. How do we do that? We use the International Space Station to create the commercial habitation requirements. Ultimately, that's how NASA becomes a customer, one customer of many, and we have numerous providers that are competing on cost and innovation. Everything I've just talked about is low Earth orbit. What we need to do after that, when that is successful, all of a sudden the costs for access to low Earth orbit go down, access goes up, and then we can use the resources that the American taxpayers give us to go even further, to do what already we're not able to do, and that is we need to go back to the moon, we need to go sustainably, and that is what Space Policy Directive 1 is all about. When we go to the moon this time, we go forward to the moon. We're not going back to the moon, we're not going to the moon, we're going forward to the moon. In other words, we're going to stay for long periods of time. We're going to go with international partners. We're going to go with commercial partners. We're going to utilize the resources of the moon. And when you think about what those resources are, Hundreds of millions of tons of water ice that we know exist on the south pole of the moon, probably more. The north pole of the moon, there's water ice as well. How much? We need to find out. But know this, we actually have a mission right now that I'm very pleased to announce. It's called Viper. We're going to take a rover to the moon with a new program we call CLPS, the Commercial Lunar Payload Services. We're buying services to go to the surface of the moon. We've got a number of companies right now that have IDIQ contracts that we have identified that we believe can take us to the moon, where NASA is not purchasing, owning, and operating the hardware, but instead we're buying a service to get activities to the surface of the moon. The reason, again, being we want those companies to go get customers that are not us, to drive down our cost and increase access. And a lot of these companies are doing just that. But we're going to use CLPS, the Commercial Lunar Payload Services program. We're going to use that to deliver Viper to the surface of the moon. Viper is going to rove on the south pole of the moon, and Viper is going to assess where the water ice is. We're going to be able to characterize the water ice and ultimately drill and find out just how is the water ice embedded in the regolith on the moon. Why is this important? Because water ice represents something significant: life support. Water ice is oxygen to breathe, it's water to drink, hydrogen and oxygen. When you crack it into its parts, hydrogen and oxygen is the same rocket fuel that powered the space shuttles. It's the same rocket fuel that powers the SLS rocket, which will be coming out of the Michoud Assembly Facility here at the end of the year, the most powerful rocket America has ever built that is going to take our astronauts back to the moon. It's a hydrogen and oxygen rocket. Here's what we know. Oxygen and hydrogen is available on the surface of the moon in hundreds of millions of tons. Rocket fuel is available on the surface of the moon. It can be used, and we need to use it, not just for life support, but even for maybe even rocket fuel. So we're going to the moon sustainably. We're going with international partners. We're going with commercial partners. We're going to utilize the resources of the moon to learn how to live and work for long periods of time. And then ultimately, we're going to take what we build, what we understand, the technologies, the capabilities, the architecture, and as much as possible, we are building the architecture to be replicable at Mars. We've already talked about why it's so important to go to Mars. Complex organic compounds. We have methane cycles commensurate with seasons. We have liquid water 12 kilometers under the surface of Mars. We need to go find life on another world if it exists. And I know that Chairman Culberson is all about this, and we're working hard to make it happen. And Chairman, you are the legacy. We're going to make sure that this gets done. So as we go forward, there's a lot that needs to be done. In order to create the architecture that we need to create at the moon, we've got to have the SLS rocket. Again, the most powerful rocket the United States of America has ever built. We need a European service module. When we go to the moon for the first time, it will be international in nature. The European service module is a critical component to the Orion crew capsule. The Orion crew capsule is how we get our astronauts to the vicinity of the moon. But there's not enough delta V there to go to low lunar orbit and land on the surface of the moon. So we need to get more delta V. Where do we get that? We are building a reusable command module in orbit around the moon that we call Gateway. Gateway is going to be in orbit around the moon for 15 years. Gateway is important for a number of reasons. We are not rebuilding the International Space Station in orbit around the moon. What we are building is a sustainable command module that will be there for 15 years that is maneuverable. Solar electric propulsion. It can go to the North Pole, it can go to the South Pole. Why is that important? There is a lot about the moon that we don't know. From 1969 up until 2009, we thought the moon was bone dry. Why? Because we landed in the equatorial regions of the moon. And we assessed that the whole moon was like those equatorial regions. 2009, we make these amazing discoveries with our international partners that there's hundreds of millions of tons of water ice, specifically on the South Pole. How did we miss it for 40 years? Well, it's because we didn't go to all of the moon. There is so much more about the moon that we need to learn. So the Gateway is maneuverable. The Gateway is also an enabler for international and commercial partners. When we build the gateway in orbit around the moon, it's going to be open architecture. When I say it's open architecture, what I mean is the way we do docking, the way we do data, the way we do information, the way we do avionics, the way we do environmental control, life support, it's going to be available and published on the internet for everybody to see. And our international partners, whether you're a big country or a small country, maybe you're a private company, you will be able to propose to NASA how you want to utilize the gateway in a unique way that will transform the human condition here on Earth, and we want that to be available to you. The goal is to enable everybody to do more. The gateway is that enabler. Now, it's not just an enabler for commercial and international partners. Here's the key. It's also an enabler for science. Historically at NASA, we have had this challenge where every dollar spent on human exploration and operations is a dollar that is not spent on science. And every dollar spent on science is a dollar that is not spent on human exploration and operations. Well, when we go to the moon with the gateway, and we have a communication architecture in orbit around the moon with our commercial and international partners, all of a sudden, the cost of doing things like astrophysics goes way down. Astrophysics is part of the Science Mission Directorate. So it is no longer a zero-sum game. By doing human exploration, we are enabling astrophysics. That's a key enabler. So we got a mission that I'm very excited about. It's being led by the Ames Research Center with other research centers operated by NASA as well. And this particular mission called DAPPER is going to help us see not just back into space or into deep space, but also back into time. We're going to see not just the first light in the universe after the Big Bang. We're going to see before the first light. We're going to see what are called the dark ages. And we can see it from the far side of the moon because it's so quiet from an electromagnetic spectrum perspective. And the reason we're able to think about this now is because we're going to have a communication architecture around the moon that includes the gateway. And that communication architecture means that we don't have to launch a $500 million, a $500 million mission around the moon. We can launch a mission around the moon that does astrophysics for $90 million because there's already an architecture of support there. In other words, we can do more science, not less science, when we do human exploration to the moon. That's a very positive development. And remember, the Viper lander is going to be on the moon as well. And we can have numerous missions to the surface of the moon with humans, some of them American, some of them with our international partners, maybe some of them commercial industry. Maybe they're interested in the platinum group metals that could be on the surface of the moon. People are familiar with rare earth metals. The challenge with the Earth is that we have a very active geology and a very active hydrosphere and a very active atmosphere, which means anything that impacted the Earth billions of years ago is not today where it used to be. It's in very trace amounts when you find it at all. Well, the moon is different. It doesn't have an active geology. It doesn't have an active hydrosphere. It doesn't have an active atmosphere, which means anything that impacted the moon billions of years ago is today right where it was billions of years ago, and that would include those asteroid impacts that are those rare earth metals, which in this case would be rare lunar metals. Now, are they there in big deposits? I don't know, and neither does anybody else. But let's go find out. That's what this is all about. Exploration, discovery, and science. Remember the science I talked about just now, how these asteroid impacts from billions of years ago could be today right where they were billions of years ago. But this is also true. The sun has subatomic charged particles coming from it and impacting with the moon all the time because it doesn't have an atmosphere or a magnetosphere. And by the way, those subatomic charged particles are probably today right where they were billions of years ago. So the moon doesn't just represent an opportunity to do astrophysics like the DAPPER mission. It represents an opportunity to do heliophysics, the study of the sun on the surface of the moon. The moon is a repository of the early solar system. So when we talk about the moon, it's about astrophysics, it's about heliophysics, the study of the sun. It's about planetary science. What can we learn about the moon and apply to other planets? And it's about Earth science. A lot of people know or believe, and I don't know, I wasn't there, but a lot of scientists believe that the moon was at one time part of the Earth. And so we can learn maybe about the early Earth by studying the moon. So all of these opportunities are available to us when we go to the moon with human exploration, and all of it enables the Science Mission Directorate of NASA. They are not, in fact, mutually exclusive. They work hand in glove, and all of us can do more when we work together. And that's not just true of the different mission directorates at NASA. It is also true when we bring with us our international and our commercial partners. That's what we're trying to build at the moon. And remember why we're going to the moon. We're learning how to live and work for long periods of time. That's what we're trying to do. Because ultimately when we go to Mars, we're going to have to be there for long periods of time. Earth and Mars are on the same side of the sun once every 26 months. That means when you go, you got to be ready to stay, friends. Some people would suggest we could do a 30 to 90 day stay. Some people suggest you got to be there for 2 years. We're working out the orbital physics. And there's other ways of maybe coming home that are unique, where you can actually do a short duration stay on Mars, where we use Venus as a gravity assist to come home. I'm not saying we're going to do that. I'm saying it's in the realm of what could be possible. But here's what we also know. We need to get to Mars. We need to continue to look and find to see if there is life on another world. The moon is the proving ground. Mars is the destination. We cannot forget why we are going to the moon. Finally, and then I'm going to open it up for some questions. When we went to the moon in the 1960s, we went under a program called Apollo. And in those days, all of our astronauts came from fighter pilot and test pilot backgrounds. And there were no opportunities for women. Well, it just so happens that in Greek mythology, Apollo has a twin sister. Her name is Artemis, and she is the goddess of the moon. This time when we go to the moon, we go under the name Artemis. We're going forward to the moon. This time when we go, we're going to stay. But this time when we go, we also have a very diverse, highly qualified astronaut corps that includes women. This is our generation. We are the Artemis generation. I am the first NASA administrator that was not alive when we had people on the moon. I was born in 1975. Our last mission was in 1972. I don't have that memory. We cannot let another generation go by where we don't have that memory. We need to get to the moon. We need to stay at the moon. We need to learn how to live and work on another world, and we need to go to Mars. This is the Artemis generation. We need to own it. We need to take control of it, and we need to make it happen. Thank you so much for having me. Okay, so I've got questions here on this laptop. There's different questions here. Just so you guys know, what is this thing called? What is it? Slido. Is that right? So if you guys want to ask questions, here's a way to do it. How far into the Artemis program will NASA deploy in situ resource utilization experiments on the moon? That's one of the questions. That's the first question. We're going to do it right away. We're hoping to do it in 2021. In fact, we're using the Commercial Lunar Payload Services program, where we're going to the moon with small payloads. We're talking about science payloads, commercially. We're not going to purchase, own, and operate the vehicles. We're going to buy services. Many in this room remember the Google Lunar X Prize. That prize, ultimately nobody won, but a number of companies got formed that we believe have capability of getting us to the moon. And we have turned to those companies and said, can you get us to the moon with a 15 or 20 pound experiment that can help us understand the regolith on the surface of the moon? And the answer was yes. We have now gone under contract with 2 companies that we believe are going to be able to deliver our science instruments to the surface of the moon in the year 2021. Now, when you talk about in situ resource utilization, are they going to be doing water experiments? Maybe, maybe not. Are they going to be able to get to the South Pole? Maybe, maybe not. But here's what we do know. We do know that we need to be able to get to the moon so that ultimately we can do those experiments, and we want to start that as soon as possible. So they will be doing experiments with the regolith as early as 2021. just so we can help characterize the regolith. Okay, another question. Could American commercial astronauts, rather than government NASA crew, be used to meet the mandate to land on the moon, the mandate to return by 2024? The answer is yes, absolutely. When we do commercial crew, in fact, one of our commercial crew providers going to the International Space Station is in fact Boeing, and they have a Boeing astronaut that will be with the crew on the very first test flight of the Boeing crew capsule called Starliner that goes to the International Space Station. So on day one, commercial is going with us to the International Space Station. And remember, what we're doing right now, we talked about the gateway in orbit around the moon and all that it enables: astrophysics, heliophysics, lunar science, planetary science, earth science, the gateway, international partners, commercial partners. People can build applications for it that include all of the above. But remember, we're also going to use it to get to the surface of the moon with commercial landers. Key word, commercial landers. We're not buying, owning, and operating the landers that go from the gateway to the surface of the moon. We're going to buy a service. The goal being that we intend for our commercial partners to go get customers that are not necessarily NASA. So it is possible that even on day one, they could have their own, just like the International Space Station, they could have commercial astronauts. We're waiting for industry to propose to us what they're interested in doing. And if they propose that, it's something we would certainly consider. Let's see. Do you foresee the Falcon Heavy or Starship helping accomplish the Artemis program? Here's the thing, we're in a source selection process right now, so it's illegal for me to highlight one over the other, say that one is going to be a part and another one isn't. But know this, we want to go to the moon with commercial landers. And Starship, of course, is a commercial lander that we anticipate will be competing in this program. Do we know that? No, but certainly it looks like they will be. But the answer is we need commercial partners, whether it's Starship or other commercial partners. We absolutely need commercial partners, not just to go from the gateway to the surface of the moon, but also to deliver cargo. I'd like to see a habitation module on the surface of the moon, a commercial inflatable habitation module. And it might be inflatable, might not. I don't want to prejudge the outcome, but I'd like to see a habitation module on the surface of the moon. That could be delivered commercially. And in some of those cases, you could go direct to the moon. In other of those cases, you would use Gateway to make it happen. So look, there are no options off the table, and yes, I see that that would certainly be a viable opportunity. Do your international partners include Chinese partners? The United States of America is prohibited by law from cooperating with China in a bilateral way. And there's a lot of reasons for that, and many people in this room know what those are. Here's the thing, at NASA, we will follow the law. and when we follow the law, we will continue to get funding. Should we choose to break the law, guess what? We will not get funding. That's just the reality that we live under. But here's the thing, and I really believe this. NASA is an instrument of American power. Not hard power, it's soft power. It's diplomatic power. Think about this. The other day, 3 days ago, I held a bilateral meeting about the Artemis program and what nations would want to join us going to the moon. And in that bilateral meeting, we had 26 different countries. This is such a positive development. 26 different countries came and said, we want to be with you when you go to the moon. Now, we can't have astronauts from 26 different countries all at the same time. But certainly, we can have international partners, and eventually, as this is sustainable, those international partners, we would love to see them on the moon too. Maybe not on the first mission, maybe not on the second mission, but we want them on the moon. We want to see American astronauts working side by side with international partners on the surface of the moon. But many of you heard the Vice President speak the other day. That you don't just get to sign up and join us. This is an element of national power where we want to say, okay, we want you to be with us, but here are the conditions that are necessary to join. And I think that is perfectly appropriate to lead free nations in that effort. And so right now we are prohibited by law from partnering with China in a bilateral way, but certainly in the future, depending on conditions, we would be open to that. But it's not just, hey, sign up and you get to come with us. How far? Okay, let's see. I'm looking at some of these I've already answered. Why does the moon landing need to be done by 2024? What will happen if the date is not met? So we looked at this. We actually did a proposal, a budget proposal that said if NASA's budgets don't change, except for maybe with inflation, if NASA's budgets don't change, how does that affect our program to go to the moon? And we put together a budget request. And we said, look, if we do it, we could do it by the year 2028. That's a 10-year program given where we were at the time. Here's what we know about history. You go back to the 1990s. We had the Space Exploration Initiative. It was a return to the moon and on to Mars. And it was very expensive and it took a lot of time. And because it took so long, it got canceled. Then we had the Vision for Space Exploration in the early 2000s. It was a return to the moon and then on to Mars. And of course, it was very expensive and it took a lot of time. And because it took so long, it got canceled. There's two risks that we deal with at NASA. Two. Well, no, there's a lot more risks than that. Two that I worry about. How about that? The most. Number one is technical risk. I can tell you this, given what I know about NASA and our engineers and our scientists and our technicians, NASA and our international partners, we can handle the technical risk. I have absolutely no doubt about our ability to handle the technical risk. There's another risk. It's political. We used to have John Culberson in the House, and he would make sure that we got what we needed to accomplish our objectives. That wasn't always the case. And if you look back in time, when we don't have people that are our champions on the Appropriations Committee, we run into problems. In this particular case, the risk is if we go 10 years, we increase the political risk. If you want to retire as much as possible the political risk, you got to go faster. So what is our goal? Our goal is to get to the moon sustainably with international partners, with commercial partners. In order to do that, we need to go fast. So I was given the task, hey, if you wanted to go as soon as you could get there, how would you do it? How much would it cost? And we came back and we amended the budget request, which is not a normal process. Chairman of the Commerce, Justice, Science Appropriations Committee can tell you that is not a normal process. But we went back and we amended the budget request to ask for an additional $1.6 billion for the Artemis program, namely to get a human landing system to the surface of the moon from the Gateway. Now we're going to buy that commercially. We're not going to own and operate it. We're going to buy it commercially. But that $1.6 billion is what was necessary to accelerate the program to, as much as possible, reduce the political risk. That's what we're trying to do. Now, if we do that, remember, everything still has to go very well. Is it in the realm of what is possible? Absolutely. Is it difficult? Yes, it is difficult. Everything has to go according to plan to achieve a 2024 moon landing. But here's what we know. If we make it a longer program, it is subject to more political risk, and that's what we're trying to retire. So that's what the 2024 date is all about. Will you make sure there is a large enough cadre of women qualified to go to the moon? Absolutely. We will make sure. In fact, if you look at the current astronaut corps, the brand new class, the newest class, the class going through training right now, is 50% women. And I think the class before that had maybe not that high of a percentage, but a good amount as well. So I will tell you this, we have great women at NASA right now. When we talk about the astronauts that will go to the moon in 2024, it will likely be one of the astronauts that currently exists in the astronaut corps. We have not selected, I get this question all the time, well, which one is it going to be? I'll tell you this, according to the president, the next man and the first woman on the moon will be Americans. I want to be clear, we do want to go with international partners. But I also want to be clear that if we're going to make this happen in 2024, we're going to need a highly skilled, already trained astronaut. And I would imagine she is already in the astronaut corps. And by the way, just because it's the next man and the first woman doesn't mean that the next two people, they could both be women, by the way. So that's, I think, also an important point to make. Let's see. What makes you think Pluto is a planet? I thought I covered that one. It's got a multi-layer atmosphere. It has an ocean. It has complex organic compounds. It has its own moons. And this idea that you have to clear your own orbit, that means that none of the planets are planets. So I am, and by the way, I like there being 9 planets. How about that? Do we have Pluto fans out there? All right. What is the process for choosing which human lander to use? We put out what we call a broad agency announcement, the process for choosing the lander. So this is the challenge, right? We're going to go fast. Why are we going fast? Because it reduces political risk. And of course, we want to go fast because the faster we get to the moon, the faster we get to Mars. It's all of the above. It's all inclusive. So when we think about how historically we have built landers for the moon or any project that NASA does, the historical way of doing it is NASA spends 6 months trying to figure out what information we need. So then after 6 months, we put out a request for information. Then we wait for 6 months while industry responds to the request for information. Then after we get that information, we evaluate all that information for 6 months, and then we put out a request for proposal. And then industry, after 6 months, they'll respond to that request for proposal. Then we spend 6 months looking at all the proposals, and we do a source selection. So 2.5 years into the program, we finally get a contractor that we decide on, and maybe a number of contractors that we decide on. And then all the other contractors that didn't win, they all protest, and then they all sue each other, and they sue NASA. And 5 years into the program, we actually get somebody on contract to actually achieve the objective. Well, we got to be on the moon in 5 years. We can't wait around for that. So we have been having some very serious discussions about how we do this. When we go this time, we're going in a different way. We're not going to create thousands and thousands and thousands of requirements. In essence, designing the spacecraft and the requirement process, we want to turn to private industry and get their feedback. And we want them to tell us how they're going to take our astronauts to the moon. That's why we have what we call the broad agency announcement. I will tell you that we have amazing contractors that are already signing up and more that will be signing up to compete. As far as giving any insight into what that competition ultimately will look like and who will win, I cannot say, but we are very excited about the fact that we have many, many interested parties in being a part of that. Let's see. Isn't human space exploration about humankind as a whole rather than which nation is taking the lead? Absolutely. When we went to the moon, it was humanity going to the moon. Was it important that the United States of America led it? I think so. There was a great power competition underway at the time. It was the United States of America and the Soviet Union, and I think it was important that the United States of America won that space race. Now, to be clear, without that great power competition, you wouldn't have had Sputnik, you wouldn't have had the first human in space, Yuri Gagarin, the first person to orbit the Earth, Yuri Gagarin. So that great power competition actually enabled, or I should say, it drove us to space exploration. You know, in some ways that can actually be beneficial for the long term. I would also say that when we landed on the moon, it changed the dynamics entirely. All of a sudden, the United States of America and the Soviet Union wanted to partner with each other. Imagine that. In the height of the Cold War, there was an amazing partnership that came together. We think back to 1975. An Oklahoman, General Tom, I'm an Oklahoman, so I'm proud of him. General Tom Stafford in 1975 was part of the Apollo-Soyuz project. And he went from the Apollo capsule to the Soyuz capsule, and we had, for the first time, a space station that was international in nature. So that drove us to a position where we were partnering. Look, competition is a driver, cooperation is an enabler. And now we went from the Apollo-Soyuz program, or if you go to Russia, it's the Soyuz Apollo program. But you go from that program in 1975, which of course was started well before that, to the Shuttle Mir program. Again, the Space Shuttle, United States of America, Mir would be Soviet. And then you go to the International Space Station. So you go back, this partnership goes back to 1975. Does it matter who leads? In my view, it does matter. Do we go together? Absolutely. And by the way, different countries can lead on different things. There's nothing wrong with that. If you're a country out there and you want to lead on something and you want the United States to be a partner, we're all about that. We want to be a partner on a lot of missions as well. So I would say if you look forward, there's going to be different countries taking different leads. I'll tell you where the United States will lead. We're going to lead a coalition of nations in a sustainable return to the moon. And by the way, because we are doing that, you know, you look at the budget, our NASA budget, $21.5 billion annually, it makes sense that we would lead. And that's a good thing. But there are other nations that want to lead in different things, and they want the United States to be a partner, and we're for that too. So yes, we all go together, and at the same time, different nations can lead on different things. I've got 2 minutes left. I'm going to close it out here. Would there be opportunities for Venus science during a potential Venusian gravity assist associated with the Mars mission? So that's way out there, but I would imagine, yes, we're not going to fly by another planet if we're not going to be collecting science on it. That's just a matter of fact. And of course, what we know about Venus helps us inform about our own planet. And what we learn about Mars helps us know about our own planet as well. We know that Mars used to have this active geology, or I should say, it used to have this active atmosphere with an ocean and a magnetosphere. The core of Mars cooled. It went from molten to being solid, and when that happened, it lost its magnetosphere, and all of a sudden, we don't have an ocean, because without that magnetosphere, without an atmosphere, the radiation from the sun and deep space dried up Mars, and it looks barren and desolate today. So these are things that inform us. Planetary science informs us about Earth science. What's happening to our own planet as our own planet changes? And no, I'm not suggesting that we're going to lose our magnetosphere, so all of the reporters here don't report that. But at the end of the day, yes, we need to get science from all these different planets, and there's opportunities to do that in the future. Remember, in the future, and I said it earlier, the moon is the proving ground, Mars is the destination. But we can go beyond Mars. There's opportunities beyond Mars. And certainly we want to go beyond Mars. So the answer is yes, we're going to get science from all these planets. All right, I'm going to close out. I've got a minute, maybe, a minute 9. I want to end by saying this. Number one, thank you for being here for Public Day at the IAC. It means that you're committed to what we're trying to achieve. You're interested in space exploration. We want to go to the moon. We want to go sustainably. Again, I cannot say this strongly enough. I'm the first NASA administrator that doesn't have a memory of where they were when Neil Armstrong and Buzz Aldrin landed on the moon. I don't have that memory. I wasn't there. I wasn't there when Gene Cernan left the moon as the last astronaut that was on the surface of the moon. We have an opportunity here as the Artemis generation to reset the standard. The standard needs to be that not only do we have a permanent human presence in low Earth orbit, we need a human presence on and around the moon, and we need a human presence going all the way to Mars. That's the objective. This generation, the Artemis generation, needs to step up to the plate and demand it. And this time when we go to the moon and when we go on to Mars, we're going with a very diverse, highly qualified astronaut corps that includes women, and we're going under the name of the twin sister of Apollo. Her name is Artemis, and she was the goddess of the moon. So thank you all so much for being interested in NASA. Thank you for being here. Let's get it done.